Okay, so let's get started. We're going to be taking a look at working with our spark timing modifier tables and programming found in our Link G5 and G4X systems. Now, our spark timing modifier tables are used to offset the spark timing that we're commanding from our main spark timing table. So they're either going to be adding or subtracting spark timing. Let's talk about this a little bit further so we can make better sense of what's going on here with these modifier tables. So what we're going to find is we have our basics page here in our course layout. Let's move over here into our spark tuning page layout here that we have. And we can find when we're in this page, we've spent the last two tutorials talking about spark timing in here. We have our main ignition timing table here. So ignition table 1. The ignition table 1 here is set up based on map pressure versus engine speed, and then we have the values populated in the table as a safe, reliable starting point for tuning, in this case, a forced induction engine, because we can see the table here is going up in map pressure above atmospheric pressure. So in this case, we can see the units are set on imperial or standard type of units, and the units are in PSI. 14.5 PSI is going to be the equivalent of atmospheric. So we can see the table here is populated going out here into our higher areas of operation, higher than atmospheric, so boost pressure. Looking at this particular table, this is going to be pretty straightforward to set up. We know we have our values here that we have populated as a good starting point. We want to reach maximum brake torque. We may not be able to do that depending on the octane of the fuel we're dealing with and the engine's compression ratio. We also want to avoid hitting knock or getting into knock conditions. So we have that balance that we're striking, trying to dial in our spark timing table values. Now, this tutorial is not going to talk about actually tuning or spark timing. We'll be seeing that coming up here in the next few tutorials. But this tutorial will talk about how and why we use our modifier tables to offset the values that we command here. So for example, I have my G5 connected on my engine simulator right now. We can see I have here simulating about 2,800 RPM speed. The ignition timing is reported as 27 degrees. So that's what we're commanding to the engine here in this hypothetical situation. We can see we're between these 2 points within the table. If I click H and take the color away, we can see we're riding here between 25 and 3,000, and then here between our load axes. So it's splitting the difference here between these values. It's interpolating and then ultimately delivering 27 degrees of timing to the table. Now, with this, a couple things that we're assuming if we're not running any ignition modifier tables. This main spark timing table assumes that the engine is warm. So we're up to about 160, 190 degrees Fahrenheit. That's typical average coolant operating temperature for most internal combustion engines. So it's also going to assume average inlet air temperatures. So we have our intake air temp sensor reading, not to be confused with charge temperature. We know they're different, but the intake air temperature reading is about maybe 60 to 70 degrees Fahrenheit. This table assumes we're in those kind of average running conditions. If the engine is really cold, coolant temp wise, or running really hot, we need to offset our spark timing, because what we command here in our main spark timing table is not going to work. We'll break down why we offset our timing and how to do that a little bit here. When we're also talking about our air temperature, so in the air temperature, if the temperature is really, really cold, we have more dense air coming into the engine. More dense air, technically we could run a little bit higher spark advance from the values that we're commanding in our table here. If we get really hot intake air temps, let's say we have a really poor intercooler on a turbocharged engine, that's going to make the engine more knock prone. So as the air temperature increases, we're going to go ahead and decrease the timing from what we command here in our main spark timing table. So the table values are going to assume that we're running our engine in average running conditions, but that's not going to always be the case, which is why we need compensation tables in play for programming so that we can actually account for what we want to truly deliver to the engine for spark timing at any given operation point. Now, the ignition modifier tables are pretty straightforward. What they're going to do is either add or subtract timing from what we find commanded in our table here. So for example, if we're commanding 27 degrees and we're at a reasonable air temperature, 64 degrees Fahrenheit, and our engine coolant temperature here, 168 degrees, those are pretty normal ranges we're going to be operating our engine in. We would want to deliver then, let's say, that gets us the maximum brake torque, 27 degrees. However, if we start to get our engine starts to run really hot, maybe 220 degrees, we want to go ahead and reduce the timing down, because at a hot engine, is more likely to knock or pre-ignite. So we want to go ahead and reduce that timing so that we don't run into the knock condition, which potentially could damage the engine. Same thing is going to happen here with our intake air temperature. If our air temperature starts to pick up really hot, 100 degrees, 140 degrees, 200 degrees Fahrenheit, extremely hot air temps coming into the engine, which will raise up our combustion temperature in the combustion chamber, and that's going to make the engine more knock prone. So we want to retard the timing and reduce the values down from what we're commanding here in the table. So hopefully it makes sense. These modifiers are either going to be adding or subtracting to our base value coming from our main spark timing table. And then depending on the condition that we're in, we may be adding or subtracting. So depending if we're hot or cold, we have some ability to offset things. So the modifier tables are used as an offset to what we command here in the table. So how do we work with these? How do we apply them? Pretty straightforward. I'm going to go up here to the engine coolant temp ignition trim. We're going to take a look at this first. If we go here to our ECT trim mode and we go from off, we have the option to turn a 2D table or a 3D table on. 2D table keeps things simple, and it's only going to look at ignition timing offset based purely on engine coolant temperature. If we turn on our 3-dimensional table, that gives us the ability to do engine coolant temperature versus engine speed, or even something like map pressure to offset the ignition timing we want to command. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.